So now we're going to talk about the determinant formula, which uses a matrix method of identifying or organizing our vectors. So we're going to calculate U cross V from the components of U and V relative to a Cartesian coordinate system. So we're going to be pulling in the I, J, and K vectors. So before we can do that, we need to talk about how to find the determinant of a matrix. If you're dealing with a 2 by 2 matrix, 2 rows and 2 columns, the determinant is the means, A times D, minus the extremes, C times B. So AD minus CB. The multiplication is commutative, but that subtraction in the middle, it could be DA minus CB, but the subtraction, those two products have to be in that specific order. So it's always going to be AD times CB. So that is when we have a 2 by 2 matrix, 2 rows and 3 columns. But in this situation, we're going to be dealing with a 3 by 3 matrix. So now we have a row or matrix with 3 rows and then 3 vertical columns. And these numbers in front, A1, A sub 1, A sub 2, and A sub 3, those are all coming from that top row. And so it's A sub 1 times the determinant. If we're dealing with A sub 1, it would be times the determinant of these 4. B sub 2, C sub 2, B sub 3, C sub 3. If we are doing A sub 2, then that matrix that we're going to multiply by, we're going to find the determinant of B sub 1, C sub 1, B sub 3, C sub 3. Those give us those 4 numbers. And if we're dealing with A sub 3, A sub 3 up here, when we choose our 4 values to find that determinant again, it's going to be B sub 1, B sub 2, C sub 1, C sub 2. And there's a very important detail for us to pay attention to here. It's positive, negative, positive. So that second term is always going to be negative when we're doing this, plus, minus, plus. And I'm going to rewrite this just with colors and different variables to kind of help you visualize if you're still having a hard time seeing what I've done. So I've rewritten our determinant formula for the determinant of a matrix, which is 3 rows by 3 columns, a little differently. A, B, and C are always going to come from the top, A, B, C, plus, minus, plus. And then we're choosing those 2 by 2 matrices by the 2 by 2 pieces that are not under that leading coefficient. So just make sure you've got a good handle on how we're setting this up because we're going to use this formula a lot. Pause the video if you think that would be helpful. And so lastly, of course, once we've set it up like this and we get here, then that A is going to be multiplied by that determinant, which in this case would be EI minus HF. And then we would continue that for those other 3, or those last 2 of the 3 determinants. So now that we know how to use this, let's talk about our determinant definition for calculating a cross product. If we have 2 vectors, U in the IJK component form and V also in the IJK component form, then U cross V, we'll put I, J, and K, thinking about that as X, Y, and Z. I, J, and K are the first row, vector U components in the second row, and vector V components in the third row. If this was V cross U, we would switch those bottom 2 rows. So once we've done this, we've set this up, we would calculate our 3 by 3 determinant. So let's do an example where we find a cross product. In this example, we are given U and V, and we're asked to calculate both U cross V and V cross U. So if I were to set this up for U cross V, I should actually give myself space to write that. U cross V is going to be the determinant of this matrix. So I've got I, J, and K. My U components are 2, +1, and +1, and my V components are 4, 3, and 1. As always, pause the video, make sure you know where I've got these numbers from. Now that I've set my matrix up, we're going to find the determinant of this 3 by 3 matrix. So I have I times the determinant, and that's going to be, since this is I, we're going to be picking the numbers below J and K. So I have 1, 1, 3, 1 minus, it's always important to remember that minus J. So the numbers that are not under J are 2, -4, and 1, 1. So I've got 2, -4, 1, 1 plus K, and the numbers not under K are 2, 1, -4, 3. So now that I'm at this step, I'm going to calculate each of these 3 2 by 2 determinants. So I have I, 1 times 1 is 1, so I've got 1 minus 3 times 1 is 3, minus J, 2 times 1 is 2, minus -4 times 1 is -4, plus K, 2 times 3 is 6, minus -4 times 1 is -4. So this is -2I minus 6J plus 10K. So this represents the cross product. This vector is normal or perpendicular to both U and V. So starting this problem, we were also asked to find V cross U. And V cross U was a property. V cross U is negative U cross V. So V cross U, doing them in the opposite order, is just giving us a vector in the opposite direction. That's negative 2I minus 6J plus 10K, or 2I plus 6J minus 10K. So U cross V and V cross U are different vectors. And of course, this property was property 3 from our our table of properties in the video which preceded this. So I hope you now feel a little more confident calculating the cross product of two vectors in R3, or in 3 space defined with 3 components.